Okay, we're going to use what we know to help us do an example on the notes. But before we do that, I want to just go over some vocabulary, some of which we know already and some of which might be a little bit new to us. So the first one I want to go over is domain. The domain of a function are the x values of the function. And for quadratic functions, that domain is always all real numbers. Okay, next we want to take a look at the range of a function. So if the domain is the x value, the range is the y values of the functions. Okay, next is the vertex. And the vertex is the highest or lowest point of a parabola, and this is what we use to refer to as the minimum and the maximum. Okay, if you remember about the axis of symmetry, the axis of symmetry is the line that divides a parabola evenly in half, and that is always written in an x equals equation. Okay, we know what the x and the y-intercepts are. The x-intercept is the point where the graph passes the x-axis, and the y-intercept is the point where the graph passes through the y-axis. And sometimes x-intercepts, we can have 1, 0, or 2, and y-intercepts we're always going to have 1. Okay, so the last two terms on our vocabulary list are the increasing and the decreasing interval. And this will be a little more clear when I show you the graph, but the increasing interval is just where the graph is increasing or going uphill when we're looking at the graph from left to right. The decreasing interval is where the line is going down or the line is decreasing when we're looking at the graph from left to right. Okay, so now that we have the vocabulary, we're going to take a look at how to interpret all this from a graph of a quadratic function. So we're going to look at this example right here, y equals x squared plus 2x minus 3. The domain in all quadratic functions is all real numbers, and that's the symbol for real numbers. It's just an R with 2 lines from it, so it's all real numbers. So any number will work in this quadratic. So we have to graph this to determine what the range is, what the vertex is, what the axis of symmetry is. So we're going to start with the y-intercept because we can get that from the graph, and the y-intercept is right here and it's -3. We need to factor this to find the x-intercepts. So if we do that, the factor pairs of -3 that add up to 2 are x plus 3 and x minus 1. So this means that our x-intercepts, there's going to be 2 of them. If x plus 3 equals 0, then x has to equal -3, and if x minus 1 equals 0, then x has to equal +1. So our x-intercepts are at -3 and at +1. So I'm going to write those right here. We have an x-intercept at -3 and an x-intercept at +1, and our y-intercept, we said, was -3. So looking at the a value, or the value of x squared here, it's positive. That means that our parabola is going to open upward and it is going to have a minimum. So now we have to find the axis of symmetry, the range, the vertex, and what parts of this interval are increasing and decreasing. So we talked about finding the axis of symmetry. The formula for that was the opposite of b over 2a. So if we look at our coefficient of a, that's 1. Our coefficient for x squared is 1. Our coefficient for x is 2. And we don't need the c, so we are just going to plug this in. It's the opposite of b, so it's -2 over 2 times 1. And that's going to give us an axis of symmetry at x equals -1. So our axis of symmetry is going to be in here, which is the halfway point between -3 and +1. So we can use that axis of symmetry for the x value of our vertex. So the x value of our vertex is -1. To find the y value, I just take my equation, y equals x squared plus 2x minus 3, and I plug in -1. So negative 1 squared plus 2 times negative 1 minus 3 if I do that whole little happy dance. And so that gives us a y value of negative 4. So my vertex is negative 1, negative 4. And so my vertex is right here. So we now know that that is the turning point of the parabola. So we can go ahead and graph that parabola in there. Here's our turning point, and it comes back up. So there's our parabola. It has a minimum because it's opening upward. Here are our x-intercept and our y-intercept. So how do we determine the range of this function? So since it's a minimum, here is the minimum value. My y-axis doesn't go any further than negative 4. So our range is always going to be a y, because our range measures the y values of the function. And in this case, everything is above negative 4. So my lowest point on my y-axis is negative 4, so it includes everything including negative 4 and everything above it. So my range is y is greater than or equal to negative 4 because it includes negative 3, negative 2, negative 1, 1, 2, 3, 4. So y is greater than negative 4. This number here and this number here are always going to be the same, just like the x value of the vertex and the axis of symmetry are the same. So now we're going to take a look at our increasing and decreasing intervals, and they're always written as an inequality with x. So if I'm looking at my graph from left to right, and I start with my parabola here, this is the area where the parabola is going down, and then the axis of symmetry and the vertex, that is the halfway point. So this is the turning point, so this is where my parabola is going up. So here's the down, and the down is from all the way over here, which is infinite, to it starts the turning point at negative 1. So my decreasing interval is every number that is less than negative 1 on the x-axis, and we're not going to include negative 1 because that's the turning point. And then that turning point brings us to the increasing part of the interval, and that is everything that is greater than negative 1. So x is greater than negative 1 is my increasing interval. So that's it for the notes. There's no Google form tonight. We are going to practice in class on Monday with this working mat. We'll have examples of this to go over together as a class and to go over individually.